Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. This is the sixth video rather, whereby I'm focusing on questions of chemical equilibrium. Yeah? Please do expect a total number of 8 questions, since I have compiled a worksheet that has 8 questions in total, and all of these questions are extracted from past exam question papers. So it's very important for you to know how to tackle exam questions. I strongly believe this will give you an edge whenever you write your final exam. So please do share the video to your peers so that they may have the same edge as you. And please guys do help us grow the channel by just subscribing. Nah? Okay. Carbon dioxide reacts with carbon in a closed system to produce carbon monoxide gas according to the following balanced equation. Nah? Okay. What does the double arrow indicate in the equation above? This indicates that this equation is reversible. Né? The double arrows indicate that the equation is reversible. Is the above reaction exothermic or endothermic? Give a reason for your answer. This is an endothermic reaction. Why? Because our change in enthalpy is positive. Because our delta H is positive. Initially, an unknown amount of carbon dioxide is exposed to hot carbon at 800 degrees Celsius in a sealed 2 cubic decimeter container. The equilibrium constant for the reaction at this temperature is 14. At equilibrium, it is found that 160 grams of carbon monoxide is present. How will the equilibrium concentration of the product compare to the reactants? Choose larger than, smaller than, or equal to. How will the equilibrium concentration compare? The concentration of our products will be larger than that of our reactants. The concentration of our products will be larger than that of our reactants. How do I know that? Because our Kc is greater than 1. Our Kc is greater than 1. Okay. They want us to calculate the amount in moles of carbon dioxide, the initial amount of carbon dioxide. Né? Please note that, guys, whenever we deal with equilibrium constant, we do not consider solids. We disregard them. Ne? Solids and liquids are not included. We only include gases and substances which are in aqueous solution. Ne? So I'll simply say I have carbon dioxide. And I also have carbon monoxide. Are you together? I have my initial moles, my change in moles, my equilibrium number of moles, and my equilibrium concentration. Are you together? I do not know the initial number of moles, so I can simply call it X, but I do know that at equilibrium I have 168 grams. At equilibrium, I just have 168 grams of carbon monoxide at equilibrium. Ne? So I can simply find the number of moles of my carbon monoxide. The number of moles of carbon monoxide, I'll simply say the number of moles of carbon monoxide. That's mass divided by the relative atomic mass number. That's 168 grams divided by for carbon, the molar mass is 12, oxygen, I have 16. So I simply have 168 divided by 16 plus 2 plus 12. I'll simply get 6 moles. So at equilibrium, guys, I would have 6 moles of my carbon dioxide. That means I've produced 6 moles and initially I had 0 moles. Né? Since I was able to produce 6 moles, I want to know how many moles of my carbon dioxide did I use. Okay, I know that I only need 1 mole of carbon dioxide to produce 2 moles of carbon monoxide. But now I did not produce 2 moles, I produced 6 moles of carbon monoxide. How many moles of carbon dioxide will I need? Just cross multiply, then 2x will be equal to 6, x will be equal to 3. This 3 represents the number of moles of carbon dioxide that were used. Are you together? Initially, I had x moles of carbon dioxide and then I used 3 moles of carbon dioxide. This simply means that at equilibrium, I will be left with x minus 3 moles. And then for my equilibrium concentration, I'll simply have x minus 3 all over 2, because I just need to divide the number of moles by my volume, right? The volume is 2 because I was told that it's a 2 cubic decimeter container. And then I also have 6 over 2, which would just give me 3. So for me to know the number of moles, I just need to find the value of x, right? How can I find the value of x? I know that Kc is equal to the concentration of products divided by the concentration of reactants. This is equal to 14. I have 3 squared divided by x minus 3 all over 2. I can simply cross multiply over there. Then I'll end up having x minus 3 over 2 is equal to 3 squared all over 14. Are you together? So 3 squared, I know that 3 squared is equal to 9. So I can simply write 9 all over 14. That means x minus 3 is equal to 9 over 14 multiplied by 2. Then x is basically 9 over 14 multiplied by 2 plus 3. That's 9 over 14 multiplied by 2 plus 3. So this is basically equal to 4.2857. That's 4.29 moles. So the initial number of moles that we had of my carbon dioxide is just 4.29 moles. 4.29 moles. Now, okay, and then now I'm supposed to state how each of the following will affect the yield of carbon monoxide at equilibrium. Choose from increase, decrease, or remain the same. 6.5.1, more carbon, if more carbon is added at this temperature. It doesn't matter, guys, how much carbon we have. Carbon will never affect equilibrium. Why? Because carbon is a solid. Are you together? So since you cannot find the concentration of a solid, whatever changes we make, this will never affect the yield of our carbon monoxide. So the yield will just remain the same. And then if the pressure is increased, an increase in pressure, guys, will always favor the side with the least number of gas moles. Now, I only have 1 gas over there, and over here I have 2 gas moles. So this reaction will favor the reverse reaction, and hence the carbon monoxide will be used up, so it will decrease. Carbon monoxide will decrease. Okay, if the temperature is increased, a temperature will always favor an endothermic reaction. Since my forward reaction is endothermic, so that means the forward reaction will be favored, and if the forward reaction is favored, the products will increase rather. So carbon monoxide will increase. Carbon monoxide will increase. That's how, guys, we're supposed to tackle that question over there. So please do stay tuned and wait for more videos. Thank you very much.